Hi everyone, so for this question it asks you to use the identity to generate the Pythagorean triple 25, 35, 37. So we're going to find the values of x and y that get you that Pythagorean triple. So basically I want to know the values of x and y would make 37 this, and then either 12 or 35 would go here. It really depends because a and b are the legs of the right triangle and they can be either or. So the first thing I'm going to do is I'm going to set x squared plus y squared equal to 37. That has to be the hypotenuse because it's the longest side. And I'm going to put the other guy underneath it, this guy, because they are very similar. The reason why they're so similar is because they have a minus sign and a plus sign and they have the same variables, and I could set up a system of equations and cancel this out and get 2x squared equals. Now what's going to go here is very important because it has to be divisible by 2, and it also has to be able, after it's divisible by 2, to take a square root. So the number that makes that happen is 35, because when you add 37 and 35 you get 72. When you divide that by 2, you get x squared equals 36, square root, and you get x equals 6. So this means that my original assumption was wrong, and I should label it like 35 and 12. This means that this guy is the 12. So 12 equals 2xy. I want to plug in x, which is 6. So I'll get 12 equals 12y, and then divide by 12, y equals 1. The next question says, if sine is greater than 0 and secant is less than 0, in which quadrant does theta lie? So first off, they're telling me sine is greater than 0, so that means sine is positive. So if you guys remember, all students take classes, this will tell you who's positive. So if sine's positive, I cannot be here or here, because that's where tangent and cosine is positive. They tell you that secant is less than 0, which means that 1 over cosine is less than 0. This tells me that this guy here must be negative. So that means that cosine must be negative, so I cannot be in quadrant 1, because that's where everyone is positive. That's what the all stands for. So I must be in quadrant 2. This question, they ask you to find tan of x. They gave you a unit circle, and I can tell that because the points are fractions, and they really should have said that, but here's the deal. We know this is a part of the unit circle because this is the coordinate points for the 30, 60, 90 triangle. So this would be 1. So tangent of theta when you have a unit circle is sine over cosine. With a coordinate point, it really means y over x. So I'm going to take the y, negative radical 3 over 2, and put it over x, negative 1/2. You can keep change flip, or you can cross off the denominators because they both have 2. A negative divided by a negative is a positive, so I just get rad 3. They ask you here to draw a diagram that represents angle alpha, which has this measurement in standard position. So the first thing I would do is probably change this to degrees because that would make more sense to me. So I'd go to my reference sheet and multiply it by this conversion. The pi's would die. I would do 7 times 180, and I would get a value and then divide that by 6, so I would get 210 degrees, which tells me that this angle is in quadrant. Well, this is 0, 90, 180, 270. So this angle is in quadrant 3. So I'm going to label this guy alpha. And then my reference angle, which is what they want you to label next, would be here. So I would label that theta. Remember, all the reference angles help you make the bow tie. So that would be a part of the bow tie. These are your bow ties. If sine of squared g and cosine squared 17 equals 1, what's the value of g? Well, g has to be 17. G is 17 because for the Pythagorean identity to work, well, not to work, to equal 1, you need the same angle inside. So here and here needs to match. For this guy, you're going to use your calculator. So if you remember, you're going to do second matrix. So you're going to press second, then you're going to press the button matrix. You're going to go over to math, and then choose R, R, E, F, and then press alpha, zoom. Make sure you have a 3 by 4, and you're going to enter all the coefficients in, and when you do that, you're going to get x equals negative 1, x equals y equals 3, I'm sorry, and z equals negative 4. So the one that's not in my solution system would be choice 2. This guy is soap because there's cubes. So remember, the first thing is soap. You take a cube root of the whole thing. That'll get you 6s plus 3t. And then we write same, opposite, always positive. So same sign, which is plus, opposite, negative, always positive. Then to get the inside of this, you square, multiply, and square. So this guy here is going to get squared to get that term. So 6s squared is 36s squared. You're going to multiply these two, the 6s and the 3t, to get 18st. That'll get you this middle term. And then to get this last term, you're going to square 3t. So it'll be 9t squared. And that is how you factor a cube. They're saying as theta increases from negative pi over 2 to 0 radians, the value of cosine of theta will what? So I'm going to plug in cosine of negative pi over 2, and I'm plugging cosine of 0. Because I'm plugging in an angle, I need to make sure that I'm in the right mode. This would be radian mode. Well, they're saying radians because of the pi and also because they say radians. When you type in cosine of negative pi over 2, when you change your mode to radian, you're going to get 0, and then you're going to get 1. So it's increasing from 0 to 1. This guy's going to be graphically. So they want you to round to the nearest hundredth, so that's important. But what we're going to do is put this into y1 and y2. We have to do this graphically because there's no other way to solve a log and an absolute value together. They're two different functions. So I'm going to first put this into y1 and y2. So I'm going to get a graph that looks like this about. And there's two intersections here. You're going to find those intersections and you're going to round. You're going to find those intersections by using the second trace command and intersect and enter 3 times. You'll get this value as 1.337912. For x, we want x because they're equal to each other. And this would get you x equals 2.855841. So 2.5855. That's really messy. Let's rewrite this. So 2.5855. But to round this properly, I had to do nearest hundredth. So the first x is going to round to 1.34, and the second x is going to round to 2.59. This question says, where's the function undefined? So what you're going to do is you're going to set the denominator equal to 0, because undefined means a number over 0. I'm going to factor this into x minus 5 with am and x plus 1, and I'll get two answers, x equals 5 and x equals negative 1, and that's where I'm undefined. They want you to write a recursive formula here, so in order to do that, you're going to remember that you need your let statement, so a1 equals 40, and then an equals something, an minus 1. Either it's going to be a multiplying or adding or maybe both. So first thing I'm going to see is that they're definitely not adding or subtracting something because of that 0.5, but maybe they're dividing. So I'm going to divide 30 by 40, and I'll also double check by dividing 22.5 by 30. When you do that, these both give you 3/4, which means that we're having a geometric sequence, and it's multiplying by 3/4. So 3 over 4 times an minus 1, this is your formula. This is asking you to find the equation of a parabola with a focus of -2, 5, and directrix of y equals -1. You need your equation of a parabola. You need to memorize this. Plus or minus 4a, y minus k. So the first thing I'm going to do is make a picture. -2, 5 is my focus. 1, 2, 1, 2, 3, 4, 5. That's my focus. And then my directrix is at -1, which is the line. My vertex is halfway in between these guys. So 1, 2, 3, 4, 5, 6. So it's going to be 6 in between. What I'm doing is 1, 2, 3, 4, 5, 6 boxes. So it's going to be 3 from either way. So 1, 2, 3. My point's right here. So I'm going to plot a point 1, 2, 3 right here. That's my vertex. Now your vertex is important. It gives you the h and k. So this vertex is -2, 2, and then you need that a value, which is the 3. It's the halfway distance. So I'm going to plug in x. You're going to change your sign, plus 2 squared, because this is h and that's k. It's a positive parabola because it's opening upward, so it's going to be 4 times 3, and then x minus 2. Oh no, sorry, y minus 2. Just clean this up a bit. You'll get x plus 2 squared equals 12y minus 2. And that is your answer. They're asking you to use the unit circle to explain why cosecant is 1 over y. Now you guys should have memorized that cosecant is 1 over sine theta. And we know sine theta is y. So basically we're just going to explain this in words. You can use the unit circle by making a picture and labeling this 1 because it's a unit circle. And then this is x and this is y. If this is your theta reference, then sine theta, which is opposite over hypotenuse, you can show that we know that that's y over 1 because that would be opposite of this angle is y and over 1 because that's your hypotenuse. So this is showing that sine is y. So you'd say something like cosecant of theta is sine's reciprocal and sine is y because of SOHCAHTOA. And the reciprocal of y, is 1 over y. Something like that. It doesn't have to be too fancy, but basically you have to say that we know that sine is the reciprocal of cosecant or vice versa. They're asking you to use the identity sine squared theta plus cosine squared theta to find the value of tangent. So if we're using this identity, we have to know that tangent is sine of theta over cos of theta to the nearest hundredth, and they tell you cosine. So we know the bottom piece of this. We know the bottom piece is negative 0.5, but we need sine, and they also tell you that you're in quadrant 3. So I know I'm in tang quadrant, so this is going to become positive eventually. So I'm going to use my identity to find sine, so I can plug that into cosine. We know cosine. Since this is negative 0.5, please put parentheses around it, because otherwise you're not going to get the right answer in your calculator. This is going to get you 0.25 equals 1. You get sine squared theta, and then you're going to solve. So you're going to take the minus 0.25 over, and then you're going to get sine squared theta equals 0.75. You could leave it as a decimal or make it into a fraction. It really doesn't matter. I think I did a fraction on the review sheet key, but either way you'll get the same answer. So we're going to take the square root now, and you're going to get sine theta equals negative square root of 0.75. Now I'm picking negative because I'm in quadrant 3, and this is tangent's quadrant. So I'm going to put this on top, and then I'm going to plug this into my calculator and round to the nearest hundredth, which is 2 places. And when I do that, I get the answer of 1.73. This question asks you to verify the Pythagorean identity for theta. So you're going to plug this theta into theta. So it's going to be sine squared of pi over 6 plus cos squared of pi over 6 equals 1. Now you will have to be in radian mode because we have pi's here. So I'm going to type in sine of pi over 6, and I'll get 1/2 and then show the squared. Cos of pi over 6 will get you 0.866, which we know is radical 3 over 2. I'll put that squared there. When you square 1/2, you'll get 1/4. And when you square radical 3 over 2, you'll get 3 over 4. Because the square root will cancel out the squared will cancel out the square root, and then 2 squared is 4. And these add together to 4 over 4, and we know 4 over 4 is 1. So 1 equals 1. Check. This question is asking you to graph sine and cosine in this domain from 0 to pi. So the first thing I'm going to do is label my axes. So I'm going to make this guy my y, and then this guy my x. I'm going to cut it in halfway so it makes sense. And then I'm going to label 0 goes here, 2 pi goes here, halfway is pi, and then half of that, 1, 2, 3, 4, is pi over 2, and then half of this is 1, 2, 3, 4, 3 pi over 2. I mean, you could make the 1 and -1 anywhere you want. You could like make it all the way at the top or at the 1, but I don't like it to be squished, so I wouldn't suggest making it one box. All right, so I'm going to graph sine first. Remember, sine starts at the origin, it goes back at 0 halfway through and back to 0 at the end. And in between here, it reaches its max, and then in between pi and 2 pi, it reaches its min of -1, and then this is your sine curve. Nice and wavy and smooth. Y equals sine x. Now, cosine's very similar. He starts at his max. He's halfway at pi at its min, and then goes back up to its max at 2 pi. Then halfway in between those guys, we have our zeros. So now I'm going to graph my nice cosine curve. That wasn't too nice. Let's try it one more time. Cosine, make sure you guys use a pencil. And you're going to label this y equals cos x.